Okay, so lesson 2.8. Okay, so today's lesson, we're going to talk about um, the correlation between the solutions to the quadratic and what that would mean in terms of the graph and how many times it crosses the x-axis. Okay, so if you remember from the last class period, when we solved, we factored, we set each factor equal to 0, and we came up with our solutions. Okay, does everybody remember that? Okay, and then our solution, so what we're going to learn today, or what we're going to talk about, is how those solutions correlate to these points here where the graph would cross the x-axis. So if we factor a problem and we get two solutions, then it's going to cross the x-axis twice. So when it says two roots, what that means is that there's two solutions. Okay? If there's one root, that means that there is one solution. So what one root would look like when we factor it is it would look like something like this. So we would factor the problem and we would get two sets of parentheses that are the same. So if I have x plus 2 and x plus 2, if I set these equal to 0, both of them are x equals -2, right? Does that make sense? So there would only be one solution. And so if there's one solution, then it crosses the x-axis at one point, and that would be the vertex of the parabola. Okay? Then the third possibility is that there's no roots. And this goes back to our last assignment and those problems where, you remember those couple problems that we had where we weren't able to factor them? There wasn't any combination of numbers that would work to factor. So if a problem cannot factor, so doesn't factor, so if it doesn't factor, then there's no roots. And if there's no roots, then that means that the graph does not cross the x-axis. Okay? So the number of times that the graph crosses the x-axis is going to be determined by how many solutions we end up with. Okay? All right. So before we get to that, let's review a couple things from this unit. So first of all, on the test, you're going to have problems where it says to factor. You're going to have problems that say solve, and then you'll have problems similar to what we're doing today, um, where we're where we're solving to find the x-intercepts. So first of all, if the problem says to factor, that's all that we're doing. We're not solving, we're just factoring. And for this particular problem here, -x² minus 6x minus 9, the only thing that these three have in common is 1, but the first term is negative. So if the first term is negative, we have to factor out a negative. So I factor out a negative, and that would change the signs of each of these terms. So this would be a +x², +6x, and a +9. Okay, so I factor out the negative. After I factor out the negative, then factor what's inside the parentheses. So factors of x², x and x. And then what do I know about the signs? This is positive. So if this is positive, this tells me both signs are the same. Look at the middle term, and that'll tell you what they're both going to be. So this is positive, the middle's positive, so both signs are positive. Okay, then factors of 9. Factors of 9 would go in these two spots here. So my possibilities are 1 and 9 or 3 and 3. And by now, hopefully, we're kind of understanding and can do a little bit of the mental math here. So if I put 1 and 9 in, is that going to give me 6? Nope. So 1 and 9 is not going to work, so I try 3 and 3. So here's our test. Multiply the inside terms together. So 3 times x is 3x. Multiply the outside terms together. 3 times x is 3x. 3x and 3x is 6x. So this is factored. So this is factored completely. Okay, and this is as far as I go. So if it says to factor, once I have it factored, I'm done. Okay, so now let's go on to the next problem. Okay, so problem number 2. What do these three all have in common? They have a 2 in common, and because the first term is negative, I'm going to factor out a negative 2. Okay, so negative 8 divided by negative 2 be a positive 4x squared. 8 divided by negative 2 would be negative 4x. Negative 2 divided by negative 2, positive 1. Okay, so now let's think of our possibilities here. So first of all, factors of 4x squared. So we would have the option of putting 4x and 1x or 2x and 2x. Those are two different possibilities. Okay, can you identify what might work? So you think 4x and 1x? So if I do 4x and 1x, what do I know about my signs? They're both going to be negative. Okay, and then factors of 1. 1 and 1. Okay, so test it. So in the middle, I get negative 1x. On the outside, I get negative 4x. Is that going to work? No, because that's going to give me what? That's going to give me negative 5x, and I'm trying to get a negative 4x. So there's nothing to switch here. The only thing I can do is to change the 4x and the x to what? To 2x and 2x. So this one, that option doesn't work. So let's try this. Let's try 2x and 2x minus 1 minus 1. So here's negative 2x, negative 2x. So negative 2x is negative 4x. Okay, and then again, the directions were to factor only. So once I have it factored, I'm done. So I would stop right here. Okay. Now, if it says, like these two, it says to solve. So if it says to solve, then after I factor, then I'm going to set what's inside each parenthesis equal to 0 and solve for x. Okay, this example here, 4x squared minus 25 equals 0. This is our special case. What is it called? Difference of perfect squares. So what times itself is 4x squared? 2x. So put 2x here, 2x here. What times itself is 25? 5. So we put 5 here, 5 here. And then difference of perfect squares, the signs are opposite. One is positive, one is negative. Okay, we're solving. So all of this is set equal to 0. And once I have it factored, then my next step is to set what's inside each parenthesis equal to 0 and solve. So I set 2x plus 5 equal to 0, and now solve this for x. So this would be 2x equals negative 5, divide by 2. So I get x equals negative 5 halves. Set 2x minus 5 equal to 0. So that'd be 2x equals positive 5. X equals 5 divided by 2. So I get it x equals negative 5 halves, x equals a positive 5 halves. Okay, problem number 4. Problem number 4, before we can factor, everything has to be on the same side of the equal sign. So before I get started, what I want to do is I want to move this negative 12 to the other side. And to move it to the other side, how would I do that? Add 12. So I'm going to do the opposite. So negative 12, so I'm going to add 12. And so now on the left side, I would have 5x squared minus 23x plus 12 equals 0. First step, and what I look for every time we factor is the greatest common factor. These three terms, they don't have anything in common. So there's no GCF. So then we're going to factor it how it is. So factors of 5x squared, 5x and 1x. Okay, factors of 12. So for 12, we have 1 and 12, 2 and 6, 3 and 4. Okay, so now one thing that we need to clear up, because we're making this a little more difficult than what needs to. When we're identifying the signs, remember, you're looking at this term right here. This is the sign that's going to tell you what's going on with your signs. If this is positive, both signs are the same. So that means they're either going to both be positive or they're both negative. So to identify what they're both going to be, then we look at the middle term. This tells you what they're both going to be. So if this is positive and the middle term is negative, then both signs are negative. If this is positive and the middle term is positive, then they would both be positive. If the last term is negative, then that's when they are different. They're opposite. One would be positive, one is negative. Well, if this last term is negative, then the signs are opposite. Okay? So if this is negative, if the last term is negative, they're opposite. Period. That's it. Okay? So now look at our options. So 1 and 12, 2 and 6, 3 and 4. Okay? Do a little bit of mental math here. So what combination of numbers, 3 and 4, okay, and where would we put them? 3 in the first spot, 4 in the last spot. Okay, so what do I get when I multiply the middle terms? Negative 3x and negative 20x, and that's a negative 23x. Okay, so now what were the directions? Solve. Okay, so to solve, I'm going to set each parenthesis equal to 0 and solve for x. So this first one, I would add 3 to the other side, divide by 5. So I get x equals 3/5. On this one, add 4 to the other side, and I get x equals 4. Okay, so these two problems, this is the example of what we did the last class period. Here's a little more practice. So this is just 2 more problems of factoring, 2 more problems of solving. Let's skip these and we'll get to the main idea for today. Okay, so now what we're going to talk about today is we're going to go one step further from what we did the last time when we were solving. So what we're going to do is we're going to talk about the correlation between the solutions and where the graph crosses the x-axis. So on this first problem, okay, hopefully this is kind of an easy one to factor for us. Factors of x squared, x and x. It's going to be 2 and 3. And what do I know about the signs? They're going to be opposite. So let's test it. So I have 2x and 3x. The signs are opposite, so it means one's positive, one's negative. Now, to get a positive 1, the bigger of these two numbers would have to be positive. So it'd be positive 3 and a negative 2. So x minus 2 and x plus 3 is how it factors. Okay, now solve it. So when you solve it, you would have x minus 2. So we're setting x minus 2 equal to 0. So that gives me x equals positive 2. Set x plus 3 equal to 0. And I get x equals negative 3. Okay, so now let's see how those two solutions relate to the graph of this equation. So if we were to graph this equation, this is what the graph would look like over here to the right. Our two solutions, so x equals 2 and x equals negative 3, those 2 points represent where the graph crosses the x-axis. Okay, so this graph right here, this is called a parabola. And these 2 points here are solutions or roots. Okay, it's where it crosses the x-axis. Now, the one thing that we need to talk about here is that for each of these graphs, there's one thing we have to be able to identify. That's whether the graph opens up like this, or if the graph opens down. And what determines that is the number in front of x squared. Exactly. If the number in front of x squared is positive, the graph is going to open up. If the number, like on number 2, the number in front is negative. So if it's negative, it's going to open down. Okay? So number 2, let's take a look at it. When we learn to graph, we'll identify how to find the vertex. Okay. For right now, in fact, here in a couple examples, I'll tell you exactly what I want you to do and what you'll need to do for the test. That's a really good question. Okay, so number 2. Here's our problem. Negative x squared plus 4x plus 5. The first term is negative, so I have to factor out a negative. So when I factor out a negative, I would have x squared minus 4x minus 5 equals 0. So we have to remember, change the signs of each term whenever we factor out a negative. Then factor the x squared minus 4x minus 5. So factors of x squared would be x and x. And then what are the only factors of 5? So 1 and 5. Okay, and again, so this is negative, so the signs are opposite. One's going to be positive, one's going to be negative. The signs yet until you do this step right here. So let's see what we get. So we have 1x and 5x. Okay, so if the signs are opposite, then I'm looking for the difference of these two numbers. So the difference of 5 and 1 is 4. So to get a negative 4, the bigger number would be negative, and the smaller number would be positive. So this would be x plus 1 and x minus 5. So now to solve, set x plus 1 equal to 0. So I get x equals negative 1. So if we look at the graph, here's negative 1. So it's crossing at negative 1. set x minus 5 equal to 0, we get x equals 5. Okay, over here on the graph, here's 5. So that's another spot where the graph crosses the x-axis. Okay, and then notice, and we talked about this a second ago, this one opens down because, why? Because the number in front of x squared is negative. Okay, now one other piece of information. So going back to what you asked a second ago, is you said, where do we put this point? I don't care where you put this point right now, but I do want you to do this, is that this graph is symmetrical. So that means that this point right here, which is the vertex needs to be halfway between these 2 points. So we had -1 and +5. So halfway between -1 and +5 is 2. Okay? So right now, the only thing I'm looking for is I'm looking for you putting the vertex halfway between these 2 points and then making sure that it opens the correct direction. That part we don't know yet. We'll learn that later. Okay? So let's look at an example. Okay? So this would be a test question right here. So it says find the x-intercepts by solving. So that's what we've been doing. And then sketch a rough graph. Okay, so first of all, before I can factor this, what do I have to do to it? Get everything on the same side. Very good. So this would be x squared plus 4x minus 12 equals 0. Okay, so that gets everything on the same side by subtracting the 12. And now we're going to factor this. So factors of x squared, x and x. Think factors of 12. So factors of 12, 1 and 12, 2 and 6, 3 and 4. We're trying to get a positive 4x. So can you visualize what numbers would go in those two spots? 2 and 6. Okay, and then what do I know about my signs if this is negative? Opposite. They're going to be different. So if they're different, then I'm looking for the difference of these two values, 2x and 6x. The difference of 2x and 6x is 4x. To get a positive 4x, which one's positive? If I want a positive, then the bigger number has to be positive. So this would be positive 6 and negative 2x. So x minus 2, x plus 6. Okay, now set them equal to 0. So x minus 2 equals 0. So x equals 2. X plus 6 equals 0. X equals negative 6. All right, so once you find your solutions, then this is how you're gonna do your rough graph here. Okay, is on the x-axis, you're gonna put a point for each of these solutions here. Okay, so your solutions are at, or your roots are at 2 and negative 6. So these are the 2 points where the graph is going to cross the x-axis. Okay, 2 and negative 6, my solutions. Okay, the next thing I'm going to do is I'm going to identify, is the graph going to open up or down? It's going to open up because the number in front is positive. So it's going to open up and then find halfway between these two. So to find halfway between these two, add them together. So when you're trying to find the middle of two numbers, you're taking the average of them, right? So negative, so let me do it over here to the side. Negative 6 plus 2 divided by 2. So negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. So negative 2 is halfway. So here's negative 2, right? And we said the graph opens up. So just put your vertex somewhere below the x-axis, and then draw your rough sketch of the graph. Okay, and in terms of being able to find this exact point, okay, well, that'll come at a later time for us. Question? I'm not. So, so you're saying the first numbers, you're saying A is negative. So this number right here is negative. So if this is negative, we'll get to that in a minute. But for right now, is all I need you to understand is this, is that if this number is positive, we're going to open up. If this number is negative, then we're going to open down. Okay, so this one right now, before I even start factoring, I know this is going to open what way? It's going to open up because this is positive. Okay, now to factor this, I'm looking for a greatest common factor. So what do these two have in common? So this point here, you're just, for right now, you're going to make sure it's halfway between the two intercepts. As far as the depth, how far below? No. The only thing that's going to matter is that if it opens up, it's got to be below the x-axis. If it opens down, it's got to be above the x-axis. Okay? So this problem right here, number 2, these two have a 2x in common. So I factor out a 2x. So if I factor 2x out of each of these, so 2 divided by 2 is 1, and then I'm taking 1x away, so I would have 1x. 6 divided by 2 is 3, and I'm taking away the x, so it would be 2x times x plus 3. Okay, so now we have it factored. So now set your factors equal to 0. And the only time we would set this part, our greatest common factor, the only time we would set this equal to 0 is if it includes a variable. So if it was just a 2, we wouldn't worry anything about it. But it's a 2x, so we set 2x equal to 0. Divide by 2, so I get x equals 0. Set x plus 3 equal to 0, so that'd be x equals negative 3. Okay, so my intercepts are at what 2 points? So 0 and negative 3. Okay, so now, where's halfway between 0 and negative 3? Negative 1.5, right? So negative 1.5, halfway between negative 2 and negative 3. Okay, or I should say halfway between negative 1 and negative 2. Okay, so the vertex is going to be on this line, right? Now, does the graph open up or down? is A positive or negative? It's positive, so it's going to open up. So if it's going to open up, what side of the x-axis is it going to be on? Above it or below it? Below it. And this is the part that you guys are asking about. So for right now, the only thing I care about is that you put the vertex on the correct side of the x-axis, which in this case would have to be below because the graph is opening up. Okay, and that is it. So on the test, okay, for these questions, this is exactly what you would need to be able to do. Okay, factor it, solve it, put the intercepts on the x-axis, and then draw a sketch of the graph. Okay, let's look at example 3. Okay, so first of all, this problem here, they're all, or I should say there's no common factor other than 1. The first term is negative, so I have to factor out a negative. And because the first term is negative, I know that it's going to open down when I graph it. Okay, so I'm going to write that up top just to remind me there. So it opens down. Now factor. So we'd have x and x. This is positive. The last term's positive. So I look at the middle term, and that tells me they're both negative. Okay, the mental math. What is going to give me this negative 6x? 1 and 9 or 3 and 3? 3 and 3. So I have x minus 3, x minus 3. So now set each parenthesis equal to 0. And both parentheses are the same, right? So if they're both the same, then do I need to do both of them? No, just do one of them. So I set x minus 3 equal to 0, and I get x equals 3. So if you remember back to the very beginning of our notes, we said there's either two solutions, or sorry, two intercepts, one intercept, or no intercepts, right? So this one has how many intercepts? 1. And where is it? At 3. So at 3 is where the graph crosses the x-axis. So this point, if there's only one solution, then this point represents the vertex of the parabola. Okay, and then we said the parabola opens which way? It opens down because A is negative. So from here, it would look like that. Okay, problem number 4. Let's try this one. So no greatest common factor. Factors of 2x squared, 2x and 1x. The last term is positive. So I look at the middle term, and that's going to tell me what they're both going to be. So they're both going to be positive. And then factors of 3. 1 and 3. Okay, mental math. What combination of 1 and 3 is going to give me 7x? So 1 here, 3 there. So inside, that would be 1x. Outside, 6x. 1x and 6x is 7x. Okay, so we factored it. Now solve it. So set 2x plus 1 equal to 0. Set x plus 3 equal to 0. So we get 2x equals negative 1. What would x equal? So x would equal a negative 1 half. And then this would be x equals negative 3. So negative 1/2. So let's go up to our graph up here. So we have negative 1/2 and negative 3. So negative 1/2 would be right here. Negative 3 would be right here. Okay, does this graph open up or down? It opens up because the first term is positive. So estimate, so on this one's a little bit more difficult because it doesn't come out to be an integer. Okay, it's going to end up being a fraction here. So just estimate halfway between these two. So I'm going to estimate halfway between to be somewhere like right here. And then it opens up. So it would look like that. Okay. All right, let's try these two real quick. So this one here, x squared plus 5x plus 6. Quick, easy one to grab, to factor. Factors of x squared, x and x. I know because this term is positive and the middle term is positive that they're both positive. And then what's it going to be? 1 and 6 or 2 and 3? Well, if I do 1 and 6, that would give me 1x and 6x, which would be 7x. So it has to be 2 and 3. So set x plus 2 equal to 0. That'd be x equals negative 2. Set x plus 3 equal to 0. That's x equals negative 3. So here's my intercepts. My intercepts are at negative 2 and negative 3. Does it open up or down? It's going to go up. So the vertex is halfway between these two. So right in here, and it goes up. Okay, next example, x squared minus 25. This is our special case. What is it called? X squared minus 25. What is the special case? What is this called? Difference of perfect squares. So what times itself is x squared? X. What times itself is 25? 5. And the signs are opposite. One's positive, one is negative. So x plus 5 equals 0, so I get x equals negative 5. X minus 5 equals 0. X equals positive 5. So 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. My intercepts are at 5 and negative 5. Where would the vertex be? The vertex would be at 0. Okay, and does it go up or down? So the vertex is below or above? It'd be below because it's got to go up. Okay. All right. Negative x squared plus 4. First term is negative, so I have to factor out a negative. So change the signs. This is another difference of perfect squares. So this would be x and x. What goes in the other spot? 2 and 2. Plus 2 minus 2. So what are my two solutions then? Well, I got x plus 2, x minus 2. So x plus 2 equals 0, so that would be x equals negative 2. X minus 2 equals 0. X equals positive 2. Okay, so my roots or intercepts are at negative 2 and positive 2. Vertex is at 0, and is it above the line or below the line? Does it open up or down? It opens down, so would it be above or below? It'd be above. Okay. What's that? This is negative, so if the first term's negative, it opens down. Yep. Okay, next one, 3x squared plus 6x. Greatest common factor is 3x. So factor out a 3x from each of these. So 3 divided by 3 is 1. Take 1x away, so it'd be 1x. 6 divided by 3 is 2. Take away the x. Okay, that's as far as I can go for factoring. So this is factored completely. Set 3x equal to 0 and solve. So that's going to be x equals 0. Set x plus 2 equal to 0. I get negative 2. So my intercepts are at 0 and negative 2. Does it open up or down? It's going to open up. And the vertex would be at what number? At negative 1. Okay. All right. And then this problem here says the room that is shown in the figure below has a floor space of, so basically this is the area of the rectangle. And it tells us that the width is x plus 3. And we're trying to find the length. So x plus 3 times something is equal to 2x squared plus x minus 15. So we know what the answer is in standard form. We're basically what we want to find out is what does this look like in factored form? So we're just going to work backwards. We're going to factor this problem. And the advantage is we already know that one of these factors is x plus 3. So all we have to do is find out what is the other factors here. So let's factor this problem. So factors of 2x squared would be 2x and 1x. Factors of 15, 1 and 15 or 5 and 3. What does it have to be? 5 and 3 because there's already a 3 here. And what is it? Yes, this tells me the signs are different. This sign's already positive, so this would have to be negative. So the length is 2x minus 5. Okay. All right, then the last problem. So we're trying to find the area of the orange part of the square. So to find the area of the orange part, we need to first find the area of the big square. So what would the area of the big square be? A squared, a times a, good. Then we would subtract from that the area of the yellow square. So what's the area of the yellow part? To find the area of a square, we multiply 3 times 3, so the yellow part is 9. So it's a squared. The orange part is a squared minus 9. And then it wants us to express this in factored form. Well, this is our special case. A squared minus 9 is difference. So how would that factor? A plus 3, A minus 3. Okay, so let's take a look at a few problems on the assignment. Okay, let's look at the first three problems. Okay, so problem number 1, this is what we are given. Okay, listen please. Okay, so problem number 1, f of x equals x minus 3. The directions for these first three is to graph. So the two things that we've graphed this year is we've graphed linear equations, which are lines, and we've graphed absolute value functions, which are the v's. Okay, so this one right here, is this a line or a v? This is a line, and it's in this form. It's in the form of slope-intercept. This number is the y-intercept. This number is the slope. Okay, so if we look at the example we're given, -3 represents what? The y-intercept. So where it crosses the y-axis. The number in front of x is 1, and that represents the slope. Okay, so to graph it, the y-intercept is -3. Okay, so this point is where the graph crosses the y-axis. The slope is 1. So if the slope is a positive 1, we would go up 1 and to the right 1, find our point, and then draw our line. Okay, that's problem number 1. Problem number 2, we are given this problem. Okay, and this is what shape? This is a V. So absolute value. Here's the general form of absolute value. Okay, so when it is in this form, the opposite of h, okay, so the opposite of h is the x coordinate of the vertex. K is the y coordinate of the vertex. And then A is basically telling us the stretch. So it's like the slope. Okay, so A, we're going to think of that as like the slope of the V here. Okay, so vertex for this problem, where would our vertex be? Take the opposite. So it'd be -1, -4 is the vertex. So -1, -4 is the vertex. The stretch or slope is 2. So from this point, what does 2 tell me to do? I'm going to go up 2 over 1, up 2 over 1. So I do the same thing on each side of the vertex. And then draw my graph. Everybody good with that? Okay, problem number 3. So on problem number 3, we are given this. Okay, now notice this time, inside the absolute value, we only have the x. So there's no h. So if there's no h, then what would x be? 0. Okay, if there's no number there, it would be 0. So for the vertex would be at 0 what? 0, 5. And a, what is the value of a? -1. So that means this time our v is going to go which way? Our v is going to open down. Okay, pretty good. Okay, on the next section of problems, 4 through 9. So on problems 4 through 9, it says factor completely. So we have x squared plus 5x minus 14. So if it says factor completely, that's all that we're doing, is we're going to factor the problem, and then we're done. We're not solving, we're not finding intercepts, we're only factoring. So to factor this, factors of x squared, x and x, factors of 14, yep, and what, doing some mental math here, what's going to give us that middle term of 5x? 1 and 14 or 2 and 7? 2 and 7. Okay, and because the last term is negative, because it's a -14, I know the signs are opposite. So if they're opposite, I'm looking for the difference of these two. So the difference of 7 and 2 is 5. To get a +5, the bigger number is positive. So it'd be x minus 2 and x plus 7. So if this was minus 5x, then it would be a -7x. Okay. 10 through 15. Okay, so problem number 10. On problem number 10, the directions say to solve. So we have 5x squared plus 10x minus 15 equals 0. Yes, so always look for the common factor first. Greatest common factor is 5, so I factor out of 5. So I would have x squared plus 2x minus 3 equals 0. Factors of x squared, x and x. Factors of 3, 1 and 3. Okay, and so if I put 1 in, put 3 in, I know the signs are opposite. So this is 1x and 3x. So I'm trying to get a positive 2x. So to get a positive 2x, the bigger one has to be positive. So it'd be x minus 1 and x plus 3. Okay, so this time, the directions are to solve, so I'm not done. Okay, I have to now set each parenthesis equal to 0. So I set x minus 1 equal to 0, solve for x. Set x plus 3 equal to 0, solve for x.